So this is my final presentation for this data science course. I'm gonna scroll up. I'm gonna talk about data science salaries from 2023. This is my final project, and I aim to explore which factors most influence data science salaries globally using real-world data and to build predictive models so that help us understand career patterns and negotiation leverage and remote work dynamics. And I use this information that I obtained from Kaggle, and it's from 2020 to 2023. Seems for me a really important data because it's showing all this data science career after the COVID, and it's a good way just to think about how the role is gonna play now doing with remote and hybrid ways of working. So I choose this data science salary because it's highly relevant concern for any of us to the entry in this field. So make us help us understand and reflects global trends, remote work, as I said, expansion, and employee expectations. I wanted to analyze that, what really impacts compensation, and beyond assumption. So I made this, why I choose this data set because it's a good candidate showing all the covers for 2020 and 2023, allowing time-based observations after COVID. Seems the same time that I start doing remote jobs. So other than that, what else? Salaries are used standardized in dollar, which help us clean consistent analysis and provides diverse global data, company size, employment type, experience level, location, and remote ratio. As you can see in the dataset columns over here, that's all information that I can obtain because a lot of impossible insights we can take from trying to predict the salary that we want to know based on this kind of experience level, the size of the company, if it's a remote or not remote opportunity or job. So this dataset contains thousands of jobs listing from different countries and tech sectors and work formats. So we're using from entry level to executive level, employment time, remote ratio, or company location size, like salary in dollar, and our target. It's our target, and well, the wide scope and standardization allow for both descriptive analysis and predictive modeling. The key findings was let's talk about the key findings. We walk through what is covered doing modeling and exploration. We import first obviously all the important libraries that we need to do this data set. We set the style to make the visualization clear, and we load the data from my path of my own computer. So we put the head so we can see the first 5 rows and can see what else is included on this data set. And after that we make a display, a describe, and info so you can see the basic information about the data set as we show over here. And after that we start first cleaning, taking all the information that we don't need right now because we have some values that's duplicated on duplicate rows, but actually we don't have missing values, nor numerical columns only. So we identify first as missing values. After that we replace missing values with the mean of the column using these transformations over here, and delete the duplicate entries. That way we obtain duplicate rows a number of 1171. After this data cleaning we have more precise information so we can explore, and we start first doing this correlation matrix and get the 5 features correlated with salary in dollar that makes more difference. So we have the work here that it happens affects the salary the most, and remote ratio is kind of not that big deal effectively, but it has a weak positive correlation actually because suggesting small salary increase for high remote flexibility. So you can see depends more on probably other factors, not only if it's remote position or no. If you have enough experience you're probably gonna have a high salary, and it doesn't matter why, if it's like remote or in presence opportunity. And after that we count all the entries. It's a good way we can see how this amount of entry you count by experience level. And you can see in this data set most of these experiences show and senior experience level, and has the most amount of data on this data set. It's going to be about this role, about professional seniority stars, such as other opportunities going to be entry level, mid level, senior level, and executive level. So it's good to see how all this information is going to be divided inside this data set. Well, other than that, we can talk about all the insights we key findings we were able to take from this data visualization we're going to use. I'm going to show in the next steps. I'm going to show the experience level show the strongest correlation with salary, and we're forcing how growth in seniority leads for better compensation. And the company size had almost no correlation, which surprised me. So bigger companies didn't necessarily pay more. It's more probably other factors like experience level of the candidate. And remote ratio also show weak correlation, as we showed like a few minutes ago. That's challenging the assumption that remote work equals higher pay as like a physical presence on a company. So on this box plot experience that we're showing right now, it's going to show the experience level, and what else? It's going to show the salary experience by level. So we're going to show the amount of salaries divided by all the experience levels that you have. And the highlights we can take from that is showing that across different experience levels, ranging from entry level to executive level, the report highlight median salaries and the presence of outliers which are in group, offering insights into the relationship between professional seniority and compensation. So there's a clear positive trend in salary from entry to executive levels, and especially in executives, suggests that some individuals in these roles earn significantly above the typical range, possibly due to geographic locations, company size, or niche expertise. So this visualization helps confirm the need to include experience levels as a significant predictor in a salary modeling. And after that, we did a regression plot that shows like the amount of salary by dollar and remote work ratio. And by this visualization, is going to show us that it's actually the regression line is almost flat with slightly negative slope, indicating there's a weak and potentially insignificant correlation between remote work and salary. As we said, you can see these two columns over here. They're going to show the amount of salaries. The higher salary is going to be in each way, if it's remote or presence, on presence opportunity of job. They're going to probably have this. They can have the probably same amount of salary. Depends on probably other conditions, maybe the experience, the location, the size of the company, or anything else. The salary distribution that we show is good because it's going to show the amount of salaries, counting the frequency, and the amount of value. So showing the higher and the most amount of salaries is concentrated between $50,000 and $150,000. That show you the great view about all the data, the amount of data you have, and salaries too. So after that, we did a box plot outlining the same amount of salary, but now you can show the concentrations of the salary, and just suggest that most lower salaries remain within our expected range. So it's good information for us to just starting this career, because the entry level is going to be probably the same amount of the range. It's not going to be that low of the people that are still working on the entry levels, and it's going to be between the range of the median of all the data science job opportunities. So you see that is a visible above 2,050, 1,100, reaching up to $450,000. So show us there's possibilities for high paying roles. That's going to show on this visualization too. But after that, we did a correlation heat map. It's going to show the salary versus the key career factors, and as possibly, for example, experience level, company size, and the work of the year, showing all the possible correlations you're going to get from this data. So you can see that salary and work year is going to be 0.24 correlation. And if you show like salary and experience level, it's going to be a moderate positive correlation. It's going to show 0.44, suggesting that experience level increase, salary in dollar tends to rise, so that aligns with the expectations that senior professionals command higher compensation in the data science in the industry. So other than that, we use the modeling for regression, trying to predict the value of the salary based on all these factors that we can analyze. And by that, we did a regression, polynomial regression, a ridge regression, and first of them, after preparing the data, we use a linear regression. With the linear regression, we got like R squared of 0.23, showing that's not that good assumption of predicting the value of the salary, possibly because we need more data, more than just the information that we have, so we can predict the salary. So these factors that we have on the linear regression, they don't explain for complete the amount of data and the possible salary that we're gonna get. So we use then after that the polynomial regression, and this model performs slightly better than linear regression with a R-square of 0.33%. So it's going to show actually 33%, right? So that's the amount of information that explains the value of the salary they're going to obtain by the result of this using this model. So meaning if you capture more salary variance by modeling nonlinear trends. And after that, we, as you can see over here first, on this predicted salaries, it's a red line. It's going to show that we have now more dots. The amount of salary, they are kind of more near and trying to follow this perfect prediction, but it still is not that good. As we said, it was like 33% of explanation of all these factors how can predict the salary in the future. So after that, we use a ridge regression, and on a ridge regression, we obtain R square, even with tuning, resulting in R square of 0.35. So it's possibly 35%, so it's slightly higher than linear, but with no dramatic improvement. So as we can see, we still have a lot of dots randomly around the predicted salaries. It's not that good. It was trying to explain all the factors that can predict the salary at the end. So most of the models struggle with the high-end salary prediction, especially beyond $2,000 and $100,000. This suggests that measured variables like negotiation skills or industry-specific bonuses matter a lot because they cannot be explained by the most range of the data that we're using. So we use AI during this project. We're using ChatGPT, for example, for generating pipelines with polynomial features and grid search for helping us with the coding part, clarifying concepts like R square, so make us easily to understand and explain all this data that we obtain for using these models. And it was really useful for troubleshooting error messages and helping us fixing the data that we got, obtaining errors, and fixing the data. For example, my file path was wrong at the beginning for taking this data, and using ChatGPT is really awesome because it showed me like it was something silly like a error on the name that was writing wrong, and then make me fix it and able to take all this data and start all this project. So it's really good if you know how to prompt. Gonna save a lot of time so you can take the right codes, and if you know what you want to ask, you just aim for, now I need like a polynomial with more options for requesting more rows so I can see another degree of polynomial regression. Can you change this code for me? So it was this kind of understanding between me and AI that helped me out go out through all these prompts that I was using, all this data set, and as I'm showing right now. So as my final reflections, this project reinforced how data-driven career planning is essential, and all the key takeaways I can say right now is experience level is the most impactful salary factor as we can analyze for now. And remote work, as working from home doesn't automatically increase salary. It's probably gonna be, depends on probably other conditions to explain that. And company size and employment type may influence lifestyle, but not necessarily pays more. Well, so by analyzing this real data, we gain clarity on where focus or growth as data science at the beginning of our careers. For anyone in this field, insight like this help us negotiate better, choose employers wisely, understand what truly affects income. So thank you for watching and have a nice one.